Okay. See here, the thread is waiting and it is in runnable queue. So what do you mean by runnable queue? So we will discuss all these queues in a moment. But for now, so we have multiple queues at the SQL Server OS level, right? So whenever thread comes executing on the CPU, and when this thread will go out of CPU if it is a SQL Server scheduler, right? There are few scenarios when the thread will go out of CPU from the Windows scheduler. One is, so the quantum will not come into the picture once I mean execution is completed. So if the execution is completed, the query execution, like whatever thread which is currently executing, if that is completed, then the thread will go out of CPU and it will be going to SQL OS, right? SQL OS, that is your UMS. It will go out of CPU. So it will not wait on the thread again, like it will not wait on the kernel, like it will not wait on the CPU. It will go out of CPU and it will be going to SQL Server, the thread, if the execution of the query is completed. Second thing is, if it needs some resources, right? If the thread needs some resources, let's say for example it needs some pages, so it has to wait on page IO latch or page latch, or it needs some lock, it has to wait to get the lock, right? So it has to wait to get the lock, that will be waiting on lock, either exclusive lock or update lock, shared lock, whatever it is. We will discuss that lock later, right? So if it needs some resources, or so if it needs some resources, or in SQL developer or SQL code, there will be some yield points, right? So yield points is nothing but, for example, this code is running this long, or this code is nothing doing nothing, then the thread has to come out of CPU. If this yield point it reaches, then the thread will come out of CPU. What is that yield point? Microsoft developer, in the Microsoft code, it is not a individual application code, it is a Microsoft SQL Server.exe. I don't know like how many of you know SQL Server.exe, mostly written in C++, right? So C++, whenever there will be certain places, they will so mention this yield points. Yielding is nothing but come out of CPU, stop your execution and come out of it, right? The same way, if this thread I met this yield point, some point of time, if it reaches this yield point, the thread will come out of CPU, right? So these are the few it has to wait, right? Resource is nothing but it can be either IO or anything you consider as a resource. So it will not be waiting and running, it will not be keep on running on the CPU, it has to come out of CPU. Yeah, so then if it is execution is completed, then definitely it will be come out of CPU and the thread will be destroyed. What if it needs some resources, right? So if it needs some resources, this will be coming out of CPU and it will be waiting on waited list. Needs some resources, right? If a thread needs some resources, it has to wait in the waited list, right? Once this thread is readily available, I mean, if the thread is ready to execute, so when it will ready to execute, if it got whatever resources it needs, right? If it is ready to execute, then this thread will be moving from waited to runnable. Sorry. So waited to runnable. The thread currently available in the runnable queue is ready to execute on the CPU, right? So you understand the difference. If the thread is waiting for some resources, then it will be in the waited queue, whatever threads, because it has to manage properly, right? The SQL OS has to manage properly. So if the thread is waiting, then it will be available in the waited queue. Let's say, for example, 10 threads are waiting. Then whichever first thread is in this list, it will go and so go and get the resources. Then it will be placed in the end of runnable list. This is your runnable list, right? So for example, first thread comes in, it will be placed here, first in, first out. Then second thread comes in, then it will be placed to the next. Third thread, then next. Fourth one, next. Fifth one, next, right? Whichever thread comes at the last, it will be placed at the tail of the runnable queue. It is a, let's say it is a runnable queue, right? Tail of the runnable queue. Whichever comes first, it will be in the head of the runnable queue, right? This is the tail, this is the head of the runnable queue. Now, so understand, so whatever threads which are in the runnable queue, it will go and execute on the CPU. Runnable queue is nothing but it is ready to run, so ready to execute on the CPU. We are not waiting for any resources, it is ready to execute on the CPU. For example, see, wait type is 0. Last wait type is memory allocation. So it was waiting for memory allocation, but currently it is not waiting for anything. It is available in the runnable queue. Once the CPU is available, this go and execute on the CPU, right? That's it. Now, so IO is nothing but input output. So whenever a thread posted an IO, so that thread will be allocated a thread in this IO list. So this will be monitored, that IO completion and all. So we have something called IOCP. So we will discuss after a few, I mean, afterwards, like, so we will discuss like UMS issues, right? This is one of the issues. IOCP is nothing but IO completion port, right? It will check whether the IO is completed or not. A thread will check IO is completed or not and all, right? So this is another queue. Once IO is completed, it is not waiting for any resources. Then the thread will go and waiting in the runnable queue again. So any queue you consider, it should go from any of these queue to runnable queue to execute. So idle thread, we will talk later. So that is leave it. So worker pool, it is not actually a queue. So worker pool is nothing but pool of workers. For example, a new task comes in, a free worker will be assigned to that particular task. That is called worker pool. For example, this execution is completed, right? First thread execution is completed. It will go out of the CPU and then it will be placed in the worker pool and available for next task, right? That thread execution is completed. That is what worker pool. Timer, this is a pool of threads, right? What threads which will be in the timer queue? It will be kind of, lazy writer. So timer is nothing but every frequently executing threads, right? Lazy writer. So lazy writer every so every second or every few seconds it keeps on executing to check if there is any memory issues or if there is any max memory or any memory changes or something. It will validate and based on that it will trigger. Or checkpoint every 1 minute it executes, right? It checks if there is any pages which needs to be flashed, right? That is a timer, right? So exact time it executes, it run on the CPU, right? Again, so it will not be run directly from timer to CPU. It will go to the runnable and it will execute, right? Now I told you, right? So whenever this is a first in first out, so whenever threads last comes in, then it should be going in tail of the queue. But what if the thread currently executing on the CPU, currently running on the CPU, and it has to come out of CPU for some reason. But the it is currently, so you can consider that even we don't consider much about quantum, it will check if there is any 4 milliseconds is completed or not, right? If a thread comes out of CPU before 4 milliseconds, so because that is a Windows level concept, right? If it thread comes out of CPU to the SQL Server layer before 4 milliseconds, before it's quantum completed, then that thread will be placed in the head of the queue, because that has to execute the next once the resources are available, right? So that has to come in the you got this point. For example, let's say Windows completely rely on quantum, right? 4 milliseconds. If the thread is come out of CPU for almost, so 2 milliseconds, let's say 2 milliseconds, it needs some resources. Then it will be in the waited queue. The thread will be placed in the waited queue. Once the thread has all its resources, then it will be placed in the runnable queue. It will not be in the end of runnable queue. It will be in the head of the runnable queue, because the quantum is still not completed. 2 milliseconds is still there. Then it is came out of CPU because some resources, it will be in the runnable queue, head of the runnable queue, and next thread, this thread will go and execute for the first time. I mean, if it is in a head, then it will go and execute on the CPU if the quantum is not completed, or if it comes in between. This is how that works. So I'll show you. So this is the runnable queue, right? So this is the worker pool. Worker pool, you can consider that. So this is a worker pool. You can consider that a few workers or few threads which are available in the worker pool, because it is not assigned to any of the task, right? So these are all normal priority. Currently, only one thread is executing on the CPU, right? So you can consider this is a timer list. This is IO list. We have different lists, right? So timer list is nothing but kind of, you can consider checkpoint or lazy writer or scheduler monitor, right? So scheduler monitor, it checks every schedule to see if there is any thread which are not yielded or something, that we will discuss later. Resource monitor, that we will discuss in the memory. So the resource monitor we will discuss here as well. I'll discuss that later. IO list is nothing but if there is any IO completion, so thread requires thread is waiting, a thread is posting some IO, right? Like for example, anything you can consider, read ahead, or so write, scatter, gather. So any IO be perform, like insert, update, delete, whatever it is. If it is going in IO list, it has to wait on IO list, right? So this thread is in this, and waited list is waiting for resources. Let's see what will happen now. So the thread which is currently running, right? So if it is, see here, it is in the runnable queue, right? So if you go back, so whatever threads which is currently running, it is coming out of CPU. It is not waiting, it is coming out of CPU because it met the yield point. I told you, if it meets yield point, it will come out of CPU. Let's consider it is not coming out of CPU because of some waits. Instead, some yield point it met. Then it is coming out of CPU and will be placed in the end of tail of runnable queue. See here, it is coming out of and it is keeping here, and whatever first thread in the runnable queue is executing, it is so spawn on the CPU to execute, right? So now let's say, see here, waiter list, we have 3 threads, right, in the waiter list. Let's say the first thread got whatever it is waiting for. Then okay, so if it is this way, like IO list, whatever IO it is posted on, it is completed the IO. Then it will be going to end of the runnable queue. See, end of the runnable queue. Next, I think, let's see, timer. So timer is, let's see, one of the thread comes in. So it needs some, it has to execute for checkpoint or something. Then the thread will be placed at the end of the runnable queue, right? So next waiter list, it will be waiting and it got the resource which is required, and it will be keep on adding to the runnable queue, tail of the runnable queue, right? So that whenever thread comes, one of the thread which is currently executing on the CPU, if it comes out of CPU, then what is the thread available, I mean head of the thread, head of the runnable queue, that will go and execute on the CPU, right? So this is how this works, so the scheduling works. So any questions so far?
Yeah, Chandu, yesterday we have discussed about everything. It's an automatically runs from the Windows side. I mean the scheduler, worker, task, threads. I mean quantum, context switching. Everything will be automatically will be done from Windows side.
Correct.
So here it's a user mode, right?
Correct.
So is there any option or like how we will be defining this user mode? How will be it will be used? This is the process, but how it will be used in our environment, real-time environment?
So environment, these are all right. So for example, let's say the thread, normally, so let's say for example, I told you, right? So whenever you posted any execution, any query, so if it is not running, right, if it is not running, then we have to check like why the query is not running. Either the query is waiting in the waited list, so or whether the query is waiting in the IO, or whether the query is in the runnable. So you'll have to check the wait types to identify what exactly is doing. So based on that, we'll have to go forward. Or if the query is running, so what exactly, how much time the query is running, and so whether the query is um, running for longer because of some so execution, that we will have to check. But this UMS, this is how, for example, in day-to-day life, if you're asking me, so this is not completely controlled by the individual user. It is controlled by the SQL server side, SQL server code level. For example, let's say you must have heard non-yielding, right? So non-yielding is because of this. If the thread is currently executing on the CPU, which is not yielded, right? Even though there is a, so some yield points are defined in the code, the thread is not yielding, right? So you will see that non-yielding dump generated. Or for example, the thread, you can consider that there can be a bug in the SQL server, right? So if that is the point, there can be a bug in the SQL server because it is not yielded. Likewise, so you'll have to check, like otherwise there are other applications in the SQL server, other applications along with the SQL server, which has spawn and running on the CPU, right? So this is only controlled by the SQL server. But if other application is running already on the same server and executing multiple threads on the CPU, then again the context switching will be happen, right, from other application to the SQL server, right? It is not within the SQL server, other application to the SQL server. So then the threads will be keep on, so context switching. That will have to check whether any other applications which are executing currently on the server or not, along with the SQL server, right? So yeah, it's pretty much right. So you cannot define, or you cannot have, or you cannot control this user mode scheduling as a user. So we'll have to check how that works, and we'll have to understand how this so whether the thread is waiting on runnable queue, whether the thread is waiting for some waiting, or how many threads are available. So that you will have to check. So another example is a deadlock scheduler, right? So we will discuss that scenarios we will discuss later, but for now, deadlock scheduler. if all threads are busy and so you have no enough threads are available, you'll have to check where the threads are stuck, right? So the threads are available in the runnable queue, the threads are in the waiter, like so where the threads are stuck and not processing, right? So that those issues we will be checking when it comes to the SQL Server.
Okay, and one more question, Chandu.
Hmm,
So you have said we have around 256 threads, and from SQL scheduler, it will assign only few threads to the only few worker threads to the CPU, as you said, right?
hmm.
I mean, why is that actually? Then how it will be run from SQL side? If it has a 256 worker threads,
Hmm.
so if it sends the task to particular CPU,
Hmm.
then remaining 256 threads, how it can be done?
Correct. Yeah, that's what we explained, right? So all the threads will be available in the SQL OS level. SQL Server, we have schedulers, right? For example, let's say we have, one sec. Right. Um, so SQL Server, we have schedulers, individual schedulers. So it is one-to-one. So in the SQL side, so we will be having that 256 will be divided. Let's say we consider only one Numa node we will discuss later. So for now, understand that we have only 4 CPUs and 4 schedulers. Scheduler is nothing but a logical CPU that we have in the SQL Server. So all threads will be so all threads will be divided at the SQL Server layer. So it will be assigned for 64 threads, 64 threads, 64, 64, right? So all threads will be allocated at the SQL level. But SQL will decide, the SQL OS will decide one thread to execute on the CPU. Until the thread is completed or until the thread is come out of CPU, it will be available in the runnable queue. It will be available in the SQL OS itself. So this scheduler.
Okay, got it.
Yeah,
So
so all 63 threads will be available in the so scheduler 0, and remaining 63 threads will be available in the scheduler 0, because we allow one thread to execute at any point of time, unless there is a multi-threading technology like so parallelism or something. But if it is not parallelism, then only one thread will execute on the CPU at any point of time. So if it is a parallelism, the same scenario. For example, let's say it needs 2 CPUs to be executed. Then instead of so one to one, so that other thread will execute on the other CPU. So if it is 4, so then other thread will execute here. So whatever thread which is there, it will be executed on the another CPU.
So this is like Windows scheduler. If it is a Windows scheduler, the task will be split through different processors. But from SQL side, if it is assigned, I mean, it will be partitioned. It will be partitioned, and that particular data will be executed through CPU, right?
Correct. So correct. So that is how that works. Like when there is a kind of so parallelism or something. For example, let's say if let's consider that two scenarios. One is not, we don't have any parallelism, and only one thread executes on the CPU, right? So we have 64 threads and only one thread will execute and on the CPU, right? So all remaining 63 threads will be in the runnable queue if it is not waiting for any resources, right? So or if there is any wait types, then few threads will be waiting in the waiter list. So I told you, right, whatever list we have actually 5 list, runnable, waiter, timer, IO, so any running. So we have these kind of list where the thread is waiting for its resources to be available. Once this is done, so all threads should go to the runnable queue. Once it is in the runnable, then if the thread comes out of the CPU, then another thread which is there in the runnable, it will go and execute. right? That is a serial threading, right? We don't have any parallelism. If we have a parallel execution, so the thread also will be split across. The threads for this particular execution also split across. It has to distribute in a round robin way, right? So if you have, if it is created 4 threads, right? So 4 threads will be split across multiple CPUs. Then those 4 threads will be executed on 4 Windows CPUs as well. The actual CPU. So four threads will be split across 4 schedulers, and these 4 schedulers will be spawned individual CPU on individual threads on individual CPU if it is a multi-threading, right? If it is a parallelism.
Okay, Chandu, sorry. Actually, still I'm confused. So when
Hmm,
will be the sequel this quantum context switching? Um, I mean yielding,
hmm,
scheduling. This everything will be happens in Windows scheduler.
correct.
So uh, how it will be worked through SQL. So when these kind of resources will be used from SQL side. So these concepts and
So
you were saying
I
that.
Correct. So I told you these 3 scenarios, right? Like when the thread will come out of CPU, so it doesn't bother whether the 4 millisecond is completed or not. But once the execution is completed, whatever thread which is currently executing, either thread execution is nothing but your query execution or your session execution, right? Once that is completed, it will come out of the CPU. So it doesn't matter whether the quantum is completed or not. So any of these are met. So if the thread is completed its execution, it should come out of CPU. Or if the thread needs some resources, or either it is a waiting or it is kind of locking or kind of, so any waitings it is needed, it has to wait on anything, it will come out of CPU. It will not wait for someone to, so kick out of CPU, but it will come on its own if it needs some resources. Or as I mentioned, like SQL developer, they will mention some yield points in the SQL code itself. SQL developer is nothing but SQL product developer, product team. So once the thread is met, this so this yield point, then it should come out of CPU. These are the scenarios from SQL end when the thread come out of CPU.
Okay, remaining all the same resources will be used from the Windows side.
Correct. Yeah, remaining so once it is executed at the CPU Windows level, then remaining all are same, right? So for example, let's consider that you have a notepad.exe application. So notepad.exe is executing on the same CPU. Let's consider on the same CPU, this one. So as I told you, SQL will allow only one thread to execute, right? So that one thread will be this. So one thread. And this notepad.exe, it also needs some thread. So it has to execute on the same CPU. Then it will be created one thread here, right? So one thread will be created to execute this notepad.exe, whatever notepad I open. So it has to execute that. Then once 4 milliseconds is completed, then what will happen? This will come out of the CPU and it will be in the available in the Windows CPU itself. It will not go to the SQL OS. It will be still available in the Windows kernel level itself. Then this will allow the notepad.exe thread to execute. Notepad.exe thread to execute. Once this thread is completed, its quantum that is 4 milliseconds, then again it will come out of CPU and this thread will execute. So only it will come out of CPU kernel mode to SQL Server only if these are any of these met.
Okay, got it, Chandu.
Okay, so the thread remains in the kernel mode if there is a quantum or if there is any context switching. So for everything, it is kind of Windows level. We will not come out of CPU to SQL Server OS if it reaches 4 milliseconds or any so very any kind of so quantum. It will not come out of SQL Server OS. It will be still available in the kernel mode until any of these are met, the completion of the execution or so if it needs some resources like waiting and all, or yield point if it meets.
Okay, okay, got it.
Is it clear, or any other confusions?
No, 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 no. I got clearly. I got it.
Okay, cool. Right, so this we already discussed. So it will be available in the runnable queue. So the threads which are in the runnable queue only go and execute at the CPU, right? So this is just so how the work will be decided, how the thread will be assigned, and it will be allowed to execute from the runnable queue. For example, let's say a new thread comes in. So if a thread comes in, it checks whether any available workers are available or not in the worker pool, right? We have worker pool where it has some amount of some workers, right? Whenever some idle workers, some available worker which are not assigned to any of the task, right? First it will check whether any idle worker available or not. If available, then assign the request to the worker and it will be placed in the runnable queue. Let's say if we don't have any idle worker, right? If we don't have any idle worker, then we'll check worker limit reached, right? So worker limit reached is nothing but uh, so but I'll discuss that when we talk about so query processing and all. But the workers will be based on the number of CPUs we have on the SQL server, right? Let's say for example, if you have 4 CPUs, it's around 256, or so 512 threads has to be spawned, right? So minimum will be 256. So it depends on the number of CPUs we have, the workers will be created at the SQL server, right? It will check whether, sorry, so any worker limit has reached. If no worker limit has reached, create a worker and assign the request, right? So it will create a worker. Let's say for example, worker limit is not reached, but we have only 300 threads created. Then it will be created a new worker and placed in the worker pool, and that worker pool so worker will be assigned to the task. Then it will be placed in the runnable queue. As I told you, runnable queue, whatever threads which are running on the CPU, it should come from the runnable queue, it should go from the runnable queue, right? It will be placed in the runnable queue. If worker limit is reached, for example, 256 is completed, reached, all threads are busy, and so 256 threads are completed, reached, then it has to wait in the work request queue, right? So work is not assigned, so it has to wait for thread pool wait type. So you must have heard thread pool wait type, right? So this is the one. So if the thread are not available in the pool, worker pool, or worker is not available in the worker pool to create, right? So there are no workers are available, then we call this as a so worker pool reached, and it will be placed in the queue. And once this worker is created, then again it will go to the runnable queue to execute, right? This is the complete life cycle. So we will so discuss this and we'll wrap up today. And this is the complete life cycle of your threads. So then whenever a thread, so life cycle is nothing but your complete cycle of your uh, thread. So for example, let's say currently the thread is running. So the thread is running. When the thread will run, it will be available in the runnable queue. Once the thread is available in the runnable queue, it will be switched and running on the CPU. If no new request, the thread will be placed in the worker pool so that it will be available for new tasks to be executed. If new task comes in, it should be available again on the runnable queue. Runnable queue, see here, runnable queue is your central right? So runnable queue is central. central from where everything goes here and there, right? If the thread is currently running, it doesn't require any resources, or it doesn't want to any so any other queues to be placed, so it will go and placed in the runnable queue, right? If the thread is not waiting for any resources, it will be going into the runnable queue, end of the runnable queue, that is your tail of the runnable queue, right? So if the timer list is nothing but your checkpoint or lazy writer, scheduler monitor, resource monitor, so that will be executed in within a interval, right? Every 5 milliseconds or every 1 second, so that will be executed every 60 seconds or something. Then that will be if that times comes in, the thread will be available, it will be moved to the runnable list. Then the thread will execute from runnable list to the runnable queue to the running queue, so the thread will be spawned, right? Then resource waiter, suppose if it is waiting for some resources, or if it needs some resources, then it will be waiting at the waiter list. So if a thread is created, if it is in the non-preemptive, so we will discuss, we were not, I mean, discussing about the non-preemptive, I told you, right? Whenever a thread is not preempted because of the quantum, or because of some high priority thread comes in, it will not move out of CPU. That is what we call it as a non-preemptive, right? So the thread will be created and it will be switched to non-preemptive. For example, let's say um, this is common behavior in SQL OS. The threads are non-preemptive, so it will not be preempted on its own. And in this worker pool, for example, threads are available in the worker pool which are idle for 15 minutes. What does it mean? 15 minutes, no workers are assigning. So then the thread, we call it as a dead. So the thread will not be, so available in the worker pool. So it will be a available worker. Then a new task comes in, a new worker will be created, and it will be, the worker will be placed in the worker pool to execute. Understand? So if it is idle, the thread which is coming out of CPU to worker pool, the execution is completed, the query execution is completed, and it is coming to worker pool. So if it is reached worker pool, then the thread, it will check whether any new task will be assigned to that or not. So if it is not assigned new task for 15 minutes, then the worker will be considered as a dead, right? This is the life cycle of your query, or your thread life cycle in simple words, right? um, 1 sec. And we have something called non-preemptive